people associate this term with Professor Schwab last year's Davos conference. When he talked about, is this term was described even before
No.
Professor Schwab when he declared the fourth industrial revolution?
Yeah, well, actually, it is the fourth industrial revolution. And if you would like to learn more, I have 2 paper copies brought with me, and who would be interested either to have a look, or I'm not prepared to take them with me back home. So if somebody would like to go, but it's also downloadable on the internet. Well, just to say this, well, maybe we can have this. This was April 2013. This was the release date of this document. And this document is April 2013. It's Industry 4.0. And this was really a result of working groups in Germany, from academia, from vendors, as well as from users. And the idea was that, you have to know, I think many of you are aware of that, about the structure of the German economy. Unfortunately, take it as you will, we do not have that many natural resources like Saudi Arabia. So we do not have any oil, we do not have any gas. The one and only thing we have are our brains and the capabilities to do something with our brains and to do manufacturing and to do innovation and whatever. And the German government thought that we should do something to really keep the German economy alive. Because there were certain threats, whatever we are talking today about digitalization, whatever it means. So if we would like to have definitions from all of you, we would get at least as many opinions or different definitions as we have people in this room. But the German government thought we have to think about what's next and how we can really keep one of our leading positions in this area. And then there were several people asked, and it was a huge group, and it's also shown in this paper, and they were thinking about it. And mainly it was about cyber physical systems. So we have some experience, and if we say 4.0, well, we have 1.0. This was James Watt and the steam machine many years back. Then you had 2.0. This was a little bit when Henry Ford started manufacturing the Model T. And then we had also automation coming into the production process, which was 3.0. And just to make it very short, there are a lot of other aspects. And 4.0 now is really that we are talking about the cyber physical systems, we are talking digital twins. So whatever a digital backbone can do for the whole product lifecycle. So we are not just talking about manufacturing. This is meant with Industry 4.0. And this was really the new idea, because there are a lot of major grants in, and this was summarized here, and out of this we got a lot of other initiatives and developed products and developed processes, and this is Industry 4.0. And there is a second paper, we'll come to this later, so most of the people are a little bit aware of Industry 4.0, and so we kept a little bit this strange spelling. This is called Smart Service Welt, and Welt is the German word, name for world. So we have also the German word in here, and this means if Industry 4.0 to some extent is focusing on the manufacturing or designing and the manufacturing, this is related to the services which are being applied after the product is in use or the plant is running and whatever. And of course, there we have also a lot of impact coming from, let's say, the digitalization part. And this is exactly why I structured also the presentation that way. So the first one will here be, the first one will be on manufacturing, on Industry 4.0. And before we start with Mainstream, the industrial platform, I will also say something on the smart cell as well. Okay, Ali, answer your question? So then, let's have a short look. As I said, we have an advertising slot for Siemens, we have a movie on Siemens.
In rapidly changing global markets, enterprises must constantly innovate in order to satisfy customer needs and stay competitive. Therefore, we've built our position along the value chain of electrification. Together with our strong competencies in automation and digitalization, we help our customers increase efficiency and reduce time to market. Electrification is our foundation and our future. Looking ahead today, designed to generate, transmit, distribute, and use electrical energy as efficiently as possible. In automation too, we have been a global player for decades, with the intention to expand even further. And we make increasing use of the opportunities provided by digitalization to generate added value for our customers. Combining our engineering and data expertise, we create truly intelligent infrastructures, seamlessly connecting the physical and virtual worlds. We drive forward the future of manufacturing. We are leading the way in connecting hardware, software, and data across all domains. And we have the know-how for turning the big data generated by billions of devices into even bigger opportunities. That's why customers all over the world trust us, count on our technological excellence, and continue to look to us for real innovation. We set new standards, making real what matters.
Well, this was a short introduction in the main areas, and the Siemens strategy is always about three main topics. And you have seen this in the movie. It's about electrification. This is where main things started. It's about automation, and it's about digitalization. This is what the company is about. Here you see a little bit of setup. We are a German company. In the next slide you see we are 170 years old. We've celebrated this year. Majority of people are still in Europe and in Germany, but nevertheless the US is the single biggest market. So it's bigger than the market in Germany. You see we are spread it out all over the world. Total figures are 380 billion a year in euros. And right now we are almost 350,000 people. What we have in the kingdom you will see in a minute. And one interesting thing is that Siemens has activities in more countries than the United Nations has memberships. It's interesting. If you look a little bit about the history, it's full of innovations, and it's Werner von Siemens who founded the company in 1847. And he was one of his major inventions in the beginning was the quantum telegraph. Another interesting aspect is the first phone call ever taken in the kingdom was taken with Siemens many years ago. It's also interesting. Then you see, Werner von Siemens was also famous in the dynamo principle. He developed this, which is still used and necessary to get DC motors up and running. And there's also the electrical streetcar was one of the inventions of him. The telephone switchboard, electrical trains. But if you look more to the recent past, one of the nice showcases here, I think you may recall what this is. This is the Mars robot called Curiosity, running on planet Mars. This was totally designed with our software. At the time where the company we acquired afterwards was not part of Siemens, but the whole Curiosity was done with the Siemens software. And also we got also some wind turbines now. We have done new plates now for low wind conditions. Plates are more than 70 meters long. This is some kind of world record as well. And we have also some software, some combustion turbines where we have efficiency of about almost 62% running in command cycle mode. If we look to the kingdom, we have also a long-term history, more than 80 years now. Our partners, Schufali Brothers, they are headquartered in Jeddah. We have these partnerships in more than 60 years. It started in 1954. And what you see here down, you see we have a mirrored organization. Whatever Siemens has globally, we have locally. Even if healthcare, which is now called Healthineers, is a separately managed company, they are here. And to be honest, we have a reasonable market share. Whenever you see a part of your body which is scanned in the kingdom, either if it is CT, X-ray, or MR, and you see it on the screen, you can have almost 100% probability that it was done with Siemens equipment. We do also a little bit of engineering and development for healthcare here.
because they are very active, find out the proper doses, which is key if you talk about X-ray, if you talk about MR or CT.
Professor Stray, what type of cooperation with FATTC? What Siemens is doing with that?
Well, when I joined, well, maybe who's not familiar with EFFERT? EFFERT is a private university being in Jeddah for females only. It's a university of about 3,000 students. And when I joined Siemens in February 2015, Aya, our CEO, asked me just get there and ask them, and just establish something. So we had no relationship to them. And at my first visit, I remember this as it was yesterday, on a Thursday, and it was, I think, 2 o'clock in the afternoon, and we were just introducing ourselves, a typical meet and greet, and then they told me, we are going to have a development of a master course on electrical engineering, a master course on electrical engineering, on energy engineering, and I told them, okay, and are you prepared to support us? I said, okay, yeah, the kickoff meeting is on Sunday, so called my assistant and came back on Sunday. And since that, we were working together with them. So I was heavily involved in developing the master course there. But we are running Siemens Days. We hire from them because we have also, as you see here, also some facilities in Jeddah. So we get a lot. We provide internships to them. Just recently, Joe Kesa, when he was here in the kingdom with Angela Merkel, Joe donated 100 million euro in software to universities. And on PLM, product lifecycle management, you will see this is more or less the stuff we are talking about later here. And we picked also EFFERT University and implemented it. Now they start the new semester, or they started already, and they also teach already this. They are really, really good. And we are working together with them also on energy automation. We will build up and back their premises. Because we found out, talking to SEC, for instance, that there is a certain deficiency in knowledge on protection, digital substations. This is a hot topic for SEC. And we will, EFFERT will address this in their curriculum as well.
How is the quality of their graduates working with Siemens? They are engineers, right?
Yeah, perfect. We got one lady, I call her now the Chief Digitalization Officer. She was a graduate from EFFERT, and we took her into what's called the Siemens graduate program. This is a 2-year program where we have 3 different locations. The first one should be in the home base, which is normally Saudi Arabia. Other 2, at least one should be abroad. And she finalized it and had the last location in the Emirates and came back, and she is now being responsible really to train the people on digitalization, and not just in the single areas, across the whole every domain. So the quality is really good. It is a really highly motivated the people, let's say the students are highly motivated, but even more what I found out is that the faculties are highly motivated. And if you come up with a new proposal, they always have the time to sit and discuss with you how to make better. And it's always a lot of fun work with them. I do not say that it's not fun working with other universities, but to some extent they have a certain spirit which I would like to see also in other universities in the country. I think Tony knows a little bit. But actually, this is really what we are going to do. So, as I said, we have a mirrored organization. These are the different, what we call the divisions right now in Siemens. We have more than 2,000 employees. So some people in the morning ask me, do you have a sales rep here in the Kingdom? So we have more than 2,000 sales rep here. So we're doing a full-fledged business. We have interesting 46 different nationalities, but even in certain areas in the company, if we are talking about a company called Iscosa, they are headquartered in Dammam doing services for fossil-fired power station. We have reached the platinum level on Saudi stations, so more than 75% of the people are Saudis. And we are going also, we hire a lot of females also in the company. We have 3 locations, headquarters here in Riyadh with about 600 people. And we have a second headquarter, which was the old headquarter in Jeddah, of about 800. Jeddah, we have also a factory doing low and medium voltage grid stuff there. And we have another location in Koba, or let's say in the eastern province, where we do digital factory, where we do process automation and drives, where we have mobility there. And we have also two remote locations in Yanbu and Zhubei, because there is a certain business for us, especially in the area of power generation and automation, where we also run a lot of. I think it's important to mention that we have the factory in the eastern provinces, also a gas turbine factory. Siemens has 3 gas turbine factories worldwide, and one is in Saudi Arabia. I think it's important to mention. The first one was in Berlin, the second one is in Charlotte in the US, and the third one is here. And we were celebrating last May, shipping the first ever made gas turbine in KSA out of the factory there. And we are very proud of this, and we hope that we get also in the future a little bit of business out of this. Okay, that's it about Siemens. If you have any questions there. Yeah.
You know, in Germany, you are designing the courses for electrical engineering students and mechanical engineers.
Yeah.
Is that right?
Yeah.
You know, as you know, my brother studied in Germany, and we started the degree the same year.
Yeah.
I was studying in England, he studied in Germany. After a while, I graduated in 2012, asked him why. I said, what are you studying? He said, industrial law. What's industrial law? He said, we have 4 courses this semester about industrial law. So I was amazed, they are embedding these courses.
In the curriculum.
In the curriculum.
Yeah, it's already there.
In the second and third year of the degree. And maybe we can take this experience.
You will see, I will come to this back later, because about the academic education is one thing, but also most important in Germany is about the whole industry, the flexibility of the industry, is the vocational training. And this is also important. And Siemens is also involved with Aramco, what's called the National Power Academy. I think not everybody's aware of this. There was an estimate made by Aramco that over the next 10 years we see a lack of about 6,000 people in the energy industry only in the kingdom, without having really the right people available. And this was the reason we founded together with Aramco, Starbuck, SEC, SWIC is also there, and GE is there. It's not just Siemens, the industrial partner Schneider is there. We founded the National Power Academy, which we train, and this is the other aspect of vocational training. But we can also talk about this. The other one is on Industry 4.0. We have a certain history, and even before we knew what Industry 4.0 was, before we defined it, we have a long track record in mechatronics, for instance. Mechatronics was something which was also coming out of Germany. This was, for those who are not familiar with mechatronics, that's a combination of mechanics and electronics. So whatever, and you have to have a certain co-design. This was the first game changer what we experienced 20 years, 30 years back, where we got the first small microprocessor, which were affordable, getting into the different devices, into the different solutions. And out of that, we could have new ideas how to do it. We could have more smartness in the devices, but also the design principles were changing. And this was, I would say, this was the first beginning of a different way to think about products. And this was also where Germany were famous for. And now these courses are also incorporated in, if they claim they have a curriculum tailored to industry 4.0, and mechatronics is one of them.
This one comment, and this is a very thoughtful comment. For example, we have big interest, and we sponsor students in Kingdom and abroad by thousands. And we are going into Industry 4.0. But this gentleman said, and this is something we've been talking to our academic partners, one of them you know very well, is that the importance of embedding the concepts of Industry 4.0 in the curriculum and in the research agenda of the faculty.
Yeah.
Because once they graduate, when the engineers graduate and join us, we're the biggest industry employer in the kingdom. It's better for our talent who are graduating and joining us to understand what is the Internet of Things, what is big data, what is cybersecurity, what is all the digitalization. So this idea is great. If academic institutions in this country embed the programs in the curriculum, that's a game changer.
Yeah. Well, maybe we can discuss it maybe at the end when we come. maybe then we have also a bigger audience to discuss this, because you learn a little bit more about Industry 4.0. But right now we are talking to different authorities, to different ministries, and it's to some extent, I'm not prepared to talk in depth on this, but we will be heavily engaged in getting things done in Italy. Just to let you know, we are discussing 4 different areas which are important for industry. The first are people, and the second one also people. The third one also people. The first one. The second one is infrastructure. So we need a certain infrastructure in the factories. We need a certain infrastructure in backbone communication, for instance. The other one are the applications. So we have to have whatever a look where we could apply this. And the third one is the way how we would like to implement it. These are the four areas we are talking to certain people that hopefully will be able to announce something very shortly. And then we'll see how things will get running. And to some extent, you will see this later also in my presentation once we talk that down to the vision. No, let's talk about Industry 4.0. And I have another movie which is not coming from Siemens, but which is coming from the initiative and showing a little bit what Industry 4.0 could be, just as a warm-up.
We have always had to concern ourselves with everything to do with increasing productivity. We need to get to the market quickly. We can't have any waste. We have to remain competitive on location. And I think that this is not just a subject relevant for management, it's important for everyone here. If we want to be successful on the market, we need to use this tool.
We are talking about Industrie 4.0. It is no longer just a theory. The practice is now being applied in many German businesses. The demands of a global competition have rapidly increased in recent years. However, in the innovative German market in particular, numerous companies have succeeded by using these challenges as opportunities. And just as the number of companies and products rise, so do the numbers of potential solutions that Industrie 4.0 can offer. Energy transparency systems now make it possible to monitor and manage all energy flows and use energy sensibly. For instance, the excess heat energy from a machine can be used to warm up other machines or to heat up the air of the production site in the winter. In order for it to work, one thing in particular must be in place.
We need transparency. What's happening where with the energy we're using? And in which areas can we possibly be more efficient? Or where can we substitute components to be able to save energy? But above all, we could sensitize our employees much, much more to the subject of energy. And that is really worthwhile.
Analyzing complex data not only saves energy, but also ensures the highest quality standards and seamless processes. Production is often about nano-precision. In the worst case, even a simple speck of dust in the wrong place could lead to an entire system malfunction. Smart networking with predictive maintenance can drastically reduce such downtime. Good samples with which the produced workpieces can be compared to by the smart system are the key. If the products deviate from the template, the system triggers an alarm. Even the smallest interferences can then be quickly identified and localized without it resulting in downtime.
I can continuously monitor the system and process as well as identify gradual changes to intervene at the right time and according to plan. By using good sample technology, we were able to improve output by 2 to 3% and overall, calculated throughout production, that is huge, huge progress.
Another example of how Industrie 4.0 can massively increase productivity is by moving away from rigid production lines and developing towards autonomous, self-organized and highly flexible production islands. They can cover a very broad spectrum of increasingly complex and individual products and significantly reduce delivery times at the same time. The smart interplay between various mobile assistants for logistics, assembly and handling particularly enables this. They support and relieve employees and at the same time ensure optimal material flow.
The smart factory is not just an example highlighting innovations. The figures it leads to are also impressive.
Wir haben je nach Produkttyp, der bei uns mit diesen...
Compared to the old system, and depending on the product type we produce with these islands and systems, we've been able to increase productivity by between 20 and sometimes almost 50%.
50% Produktivitätsverbesserungen erzielen können.
And at the same time, we've achieved lead time reductions of over 60%.
Von über 60% zu verzeichnen.
Less rejects, lower energy consumption, less down and setup time. Instead, more quality, more flexibility, more output, and improved working conditions. With its versatile innovative solutions, the German electro industry is on the best path to Industrie 4.0.
Yeah, this was a short movie showing a little bit the setup of the high-end factories in Germany. You see, there are still some people, but a lot is automated, and you saw a lot of people walking around with tablets or smartphones and controlling the process. These are some of the aspects of Industry 4.0. So now let's start. And as I said, we have the paper copies here. If somebody is interested in, can have a look or take also one.
Is it available online?
What? It's also online. It's available online after. Okay, it's not. Maybe we'll have the reference here, but I can also give you the reference. So what is it about? And Industry 4.0 is, as I said, the fourth industrial revolution. We talked about the first three already. And the interesting point is it's not just about manufacturing. Most of the people think it's about manufacturing, but it's not just about manufacturing. It's across the whole value chain. And whatever a value chain of a product is, we will see this in depth as an example in automotive industry. But it's, by the way, you could get the slides afterwards. You have to take all the pictures. But you like to take pictures, but it would be easier. You could have a PDF as well. That's not a problem. So it's really about the whole product. It's about the life cycle chain of products. So, and one of the buzzwords, or which is sometimes used with Industry 4.0, if you would like to explain it, just in an elevator speech of 30 seconds, is something like a digital twin. Whatever you have in reality, you have a twin in a computer. And whatever you are doing during the life cycle process, having the first idea, having the first designs, then developing it, manufacturing it, operating it, as well as serving it out there. There you have always data, information in an IT backbone, which is used in a seamless manner. This is what Industry 4.0 is about. And you will see this later much more better in an example. So it's also the integration of what's called cyber-physical systems. So some people call it embedded controls. We have some mechanics, and we embed microcontrollers, then we have cyber-physical systems. This is what's called cyber-physical systems. And it's also the matter how you do logistics with that. Because if you look, for instance, 3D printing, additive manufacturing. This is not a part of, but this is one of the technologies which could be used in Industry 4.0. Because at least you need data to run the printers. So as you need a Word file to print out something as a text file, or you need PowerPoint to print out some slides, you need also data to print 3D printing. But this could change totally logistics, which means you have not to be on site, because you could easily develop something in Saudi Arabia, and it could be printed out on the other side of the world. It could be printed out in New Zealand. There's a lot of other questions there. So who ensures quality? This is something where IP rights are not that clear. So the open source is clear, but at the end of the day, you would like to make also some money out of this. So these are some open questions, but from the technical point of view, it's also feasible, it's possible today. But this has impact on logistics, because you just ship data, and you have to ship the raw material. But the raw material could be provided locally, and it could be shared with other manufacturing. It's not dedicated to a certain product. So this is also where Industry 4.0 has a certain impact on logistics. And in principle, also IoT, Internet of Things. So every device can talk, every device can provide data, and would also accept data, would accept something which influencing the behavior, influencing features is possible. And actually, it's
all about, and this is what I said, it's not related to manufacturing, it's the whole value chain. It's also about business models. And 3D printing is a very good example. You just do the design, but manufacturing could be totally different. Could be on the other side of the world. Could be done by a totally different company as well. This is really the point. If we look here, it's the horizontal integration through networks. That's clear. We addressed, and we will see this in depth later. The whole value chain in horizontal will be addressed by Industry 4.0. Then we have an end-to-end engineering, which means whatever we gain on data, on experience at the very end, operating the product, we can use it either to optimize the manufacturing, or even what is easily can be done, also optimizing the design or changing the design and start the thing again. And as this is everything is digitized, and you will see this later as one of the advantages, it takes shorter time, and it's much better in terms of final quality, what you get out of this process. Then we have also the vertical integration. We have the vertical integration, which means we could use the whole value chain also in a certain area, in a certain vertical. It could be in oil and gas, it could be in pharmaceutical, it could be in petrochemical, it could be food and drugs. There are many industries. Even if we have the automotive industry as an example later, we should you could imagine that these basic principles could be applied to all the industries. It could also industries, and also to industries which are just providing services. Even there, we have some gaps sometimes in the IT backbone, in data. It's not consistent. It's not, sometimes, well, if you look to engineers, I just had a Siemens Day at Kicks Out University here, and we were talking about the university. It's really disappointing for an engineer, yeah? But they're right. Well, sometimes engineering work today is you get an Excel sheet, it's the wrong format, and hopefully you get an Excel sheet, you just copy and paste it to another Excel sheet. This is sometimes the work engineering is done today. Could be easily done by a computer. Sometimes it's even worse. You get a paper copy of an Excel sheet and you just type it in and put it in another form. These are many things. And whatever follows fixed rules could be done by a computer. And guess, if you're not aware of this, just remember, we just were celebrating the 10th anniversary of a smartphone. Steve Jobs was introducing the first iPhone 10 years back. And today, well, sometimes we are using them to take a call. But most of the time we are using totally different. And there is an endless way how to, on application of new ideas, how they can do this. Yeah? And think about this in engineering. Think about this, what we have achieved so far in industries, and just approximate this for the next 10 years. Nobody can really forecast, even though it will happen in the next 3 years. But this is really what the point is.
Another question. Sorry. This type of new technology, can be applied for new industrial products or also can apply for all the products?
I would say it would be easier if you start from scratch, if you start from new products, because you do not have any history, you do not have any non-believers in the company who will not support this. So I think in principle, Industry 4.0 is applicable to existing products, existing industries, as well as to new products. It would be easier if you start from scratch. You have to start with Industry 4.0, so you're coming faster from day one. But it's possible with all industries.
Sorry, the second question. I think if we will use this type of technology, it will help on the manpower of the factories. And we are looking for opening channels for manpower. And you will see that the new technology towards two profits. So how we can compromise between the two parties?
You know, this, especially in Germany, it's always a big discussion there.
Yes.
With the workers' council, what will happen to the stuff sitting in the factory and so. But by the way, it's also interesting. Do you know this show? How the factory of the future will look like? Who will be in the factory?
Robotics? Robots? No.
It will be a dog.
A dog.
Sorry? A dog and a man. The dog and a man.
And what the robotic will do?
So, what are the responsibilities? The dog will take care that nobody is entering the factory, and the man will feed the dog. That's it. Well, this is just a joke. No, actually, but the experience we made, and this this is always an argument, to some extent it's vague, except it's vague, is that right now what we in Germany is that we got rid of some jobs, but we created a lot of new jobs. The point is, if you have somebody, a blue-collar person, who is running in a factory today and doing some mechanical work, he might be able, it depends a little bit also on the age, to re-educate him and to do a little bit of maintenance in the modernized world on computers. But to be honest, it's also a question of generation. So if you are 5 years to retire, you will not be able, and you have worked all life long in mechanics, you will not become a world-class programmer or software engineer. That's impossible. But it totally coming from the governmental point of view or the workers' council point of view, what we see is that introducing these kind of industries is creating more jobs than it is diluting at the end of the day. So, and this is really a matter of fact. But, and this is also one of the main problems I see here in the kingdom, you have to have the right people to start with. And you have to have the right educational background and educational setup to train the right people. And this is where everything should start with.
Dr. Now, because to be honest, the very same conference we're attending, yesterday we heard a speech, and they highlighted Industry 4.0. This gentleman at the podium, he said, well, this will result into exactly what this colleague is saying. People will be redundant in different countries because you have robotics and you have artificial intelligence, which will eliminate the need for having people working. But at the same time, we hear another message, and this is the contradicting message. Somebody is saying, no, the Industry 4.0 will create knowledge-based jobs that require high level of intellectual capability with digitalization.
Yeah.
So which view?
No, both views are right. Both views are right. But the point is,
I have seen last week some statistic about this subject. They said that some countries that with low level of education affected more than other countries. For example, UK, I think it's affected with points, maybe 0.1 or less. But countries like India or Indonesia, they're affected with maybe 2 or 3%. So I think this is maybe the key.
yeah, but if you look also to the industries, well, I wouldn't agree on UK as a German, but this is a different story. First of all, if you look to the history of the UK and the current status, especially with this Brexit, what they are facing in the next years, they are running directly into total disaster. Because they just make, the main GDP was making money from money. There is no really production industries any longer. And the Brits were very, very strong before this thing. But this is a different story. No, but the point is, even if you compare industrialized countries to emerging countries today, and you look to the factories, you see that a lot of more stuff is used in the factories in emerging and developing countries than in industrialized countries. So the impact, of course, is different. But actually, there are two views are right. But the first one is, it's still creating more jobs. It's creating more jobs than they replace by robots. But the other point is that the people who have done the old jobs are not feasible to be re-educated to do the new jobs. And this is, then we are talking about a problem of generations, we are talking a problem of time. No? But this is the way it is. No? That's the way it is.
So did you make a comparison between the both ways, for example, I mean, if these factories use all the technology and now if it's used for this new technology, what is the advantage and disadvantage of each?
I will answer your question in a minute if I go a little bit further, because otherwise I will first be run short in time, but on the other side, I will have all these answers are within my story, so we can come to this later. Okay. So this was now, and we said also about the new social infrastructures in the workplaces also that you could, for instance, if you are doing engineering, on a computer, you can work from home. Yes. If you look to the big cities, you have best example, well, all over the kingdom there are big traffic jams. So why to get in the office in the morning if you can do the same job from home? Of course, you need the right infrastructure, you need bandwidth, but the kingdom is not that bad. At least
compared to Germany, I'd like to stay in my apartment here in Riyadh, because I have at least 3 times the bandwidth I have in Germany. And in Germany, they promise me, I pay for 50 megabytes, but actually I get something like 15 or something like that. Okay. So now, if we look, what's really meant by this is the horizontal integration through the value networks. So we have new business models. We could do this differently. We could have new ecosystems out of the new business models. Also, business processes, end-to-end engineering could be different. So we could think about the whole value chain. And manufacturing system, as discussed before, will have a much more flexible discussion. The manufacturing through to modular systems, autonomous systems, or machine learning. You will come to this a little bit later. So how looks the future of manufacturing now? And this is what we can see here. If we look to the industries in general, we see 3 major requirements or demands. The first one is an increased efficiency. It's reduction of energy or higher efficiency in energy consumption. Also resources, of course. We do have a shortened time to market. People would like to get it faster than that. Also, one of the trends I see with Industry 4.0, in the old days when there was a startup and there was a new company coming up, the new company was always beaten by the bigger company. But they had all these experience, they were much more experienced in doing things. And this has just turned around. Today, the smaller companies are beating the bigger companies if they are not getting more flexible. First, there are a lot of more opportunities using IT. But if you have old companies or big companies, sometimes they're very old, like Siemens, 170 years. And if you're not keen re-innovating you or reinventing you each and every day, you get a little bit slower on this side. You get a lot of processes which are not reviewed on a daily basis, on a weekly basis, on a monthly basis. So this is what you really have to do. And today, one of the trends we see in industries, and this is also shortened time to market, that the smaller companies and the younger companies are beating the older companies, right? Because they are more flexible. They are open for new technologies. And the last one is also enhanced flexibility. And I was talking about one of the buzzwords with Industry 4.0, which is the digital twin. The other one is normally also what I call the batch size of one, which means you could do today highly customized products with Industry 4.0 because all the data is kept in the computer. You can customize this and finally manufacture it with the quality of a mass product, but just as a highly customized product. This was a contradiction in its own, because normally in the past you have to have certain statistics that you reach a high quality, and over the time it got better and better and better. Today, many things are done by robots. Quality is more or less constant, and you can use everything for really a batch size of one, which means a single product, highly customized, is manufactured, and it has the same quality as it was done in the past 1,000 times, 10,000 times a day or a week.
This is a good question, clarification questions. Energy.
Yeah.
Energy and resources. Energy, traditional sources of energy, oil and gas, or alternative like solar, wind. Which energy meant by it? Is it energy at large or traditional versus alternative energy?
No. This is just energy in general. Energy in general. So, well, most of the, if you go to the factories, most of the time the electrical energy is used, and it's independent if it's coming from fossil resources or coming from renewable. It's getting more and more renewable, but this is a different aspect. This has nothing to do with Industry 4.0. And by the way, we got in Germany last year, we got now up to 33% of renewable energy being used in the whole country. 33% already. So the generation resources are almost the same, 100 gigawatts renewable, 100 gigawatts fossil fired, and out of this we get almost one third. And even the first half of 2017, these are the figures from 16, 17 are 38% now. So we get a lot more. But this is different. But look, if we have, for instance, different motors today, which are being used in the workshop. Right? And new motors actually come with an efficiency increase of 15%, 15-20%. Frequency control motors is normally the thing. If you have heat recovery, this is one thing. A lot of heat recovery can be done. You can use the exhaust heat even to cool something or to heat something up. This was also shown in this example, what we have seen in the movie. And this is what energy is about. And of course, there are also a lot of new methodologies and new manufacturing processes which are designed under the aspect to be more energy efficient. And it's also interesting. One of my former colleagues, he's now with ThyssenKrupp, and he's a direct report to the CEO to Hiesinger, and he told me you can't change the way you cook steel, for instance. Cooking steel is cooking steel. It's like doing refineries. And you have to do it. But what you could do is you can have a different kind of post-processing, and you could have a different kind of pre-processing. Yeah? And this is really where a lot of potential is, and where we could also do a lot of more energy efficient processes. We could establish a lot of more energy efficient processes. Yeah? Okay. So then, what the other aspects are, we have a fusion of the virtual and the real world, and this is what ended up in what we call the digital twin. So whatever we do, we can do it also before in the computer and make it shorter, because we can work overnight. The computer can do a lot of simulation, do a lot of variants in a very, very short time. And we will get a little bit later an example in the automotive industries. The virtual image is under physical systems. We can have we can gain experience already in the computer, and then we have really the plug-and-play procedures what we are going to use in the computer industry, also in manufacturing. And we have a dynamic production network which is flexible, as I said, edge size of 1, which is much faster as well. So now, if we look digitalization, and Industry 4.0 is to some extent digitalization. It's part of our daily life in all the different divisions of Siemens. We will come to the very end, we will come to this, but if you look today, we will go with Digital Factory, and you can see here, we will focus on the automotive industry, just to make it as an example, but keep in mind and be flexible in thinking, whatever we discuss about the automotive industry could also be used for other industries. And if you have some questions, we can discuss that. So if we look there, again, we have different requirements, speed. We have to be faster. As I said, big companies are beaten by the smaller companies because they are faster, they are more flexible. Flexibility means not just being fast, but being also flexible in doing changes, getting more customized products there. Then quality, this is the other thing. If you've seen some of in the movie, the workshop floors there, you see a lot of robots working. And robots they are not getting tired. They produce the same quality on a 24/7 scale. And this is where we have speed, or we can manufacture more, or we can use the utilization rate is higher, and the quality, of course, is better. And out of this, efficiency, energy efficiency is one, but also using resources. If you look to, for instance, 3D printing, additive manufacturing, which means also that we could use, we could get a lot of more efficiency out of this. Right? I don't know if you're aware of that. The standard 3D printing is clear. You could have some shapes which aren't able to cast, for instance. Right? This is one crazy thing, you know. Right? But the other thing is, I don't know if you have seen this, print free to the air, 3D printing, print free to the air. You could do the construction, and you could replace the steel in concrete by fibers or by polymers. And thus, you could have totally different shapes. And today, the thickness of concrete and therefore the amount of concrete you need for a certain construction is limited by the steel which is used, because you can't bound it that much. But if you now print free to the air polymers, then you could use less concrete, and have different shapes. But out of this, you have the need of less cement, and what's more important for the king, less water. And this is efficient. This is the efficiency if you think it really to the end. If you have less concrete, you need less cement. Cement is also, manufacturing cement is a very high intensive industry, and you need less water, which is important if you talk about a country which has, 98% coming from desalinated water.
Professor Spade, now looking at our manufacturing landscape, how do you see us in Saudi Arabia among compared with these four components? Do you see that these components are currently present in our manufacturing landscape?
Well, they are all representing the manufacturing landscape. Yeah. But there are different let's say levels of maturity, and there are different potentials of improvements. So we do have an industry which is pretty good to some extent, but at the end, there is always room for improvement concerning flexibility, energy efficiency. Well, especially energy efficiency. I think everybody's aware in this room that energy is by far too cheap in this country, and it has to. We have really to come maybe not to the world standard, but at least even if you would double or triple the tariffs for water or the tariffs for electricity, you are not getting close to any other country in the world. And therefore, energy efficiency is not in the prime focus in building up the industry. On the other side, you could take it the other way around, because energy is so cheap. Why not really focus on industries where a lot of energy is being used? Because this could be a competitive advantage. And then, if you do it differently in terms of being faster, being more flexible, this could really be the killer application for the rest of the world.
I'm just surprised why, for example, human capital or talent is not among the 4 requirements for.
This is exclusively seen from the technical perspective. For sure, it's all about people. Okay, so now if we look what's happening in the industries, it's changing the way products come to life. So we have different design principles. So one of the things is we are talking about the systems of systems. So the world is becoming complex. We have a lot of systems which are now combined to a new system, and we have different aspects. So co-designing is something which is becoming more and more important. This means you have to have a shared database, you have to have a shared backbone, an IT backbone. Generative design, I don't know if you have heard about this. This is about how the industry mimic the mother nature, how to develop something in the evolutionary way. It's comparable if you develop software. I don't know if you're familiar with software development processes, agile methodologies. You don't write a full functional specification in the beginning or requirement specification. Start development, and after 1 year, it's a big surprise what you get delivered from the IT guys. So we have agile development, we have scrums, we have sprints. We just start with something, they are doing something overnight, they are showing what they have done. Then we say, it's okay, it's not okay, they do it again. But this is really becoming much faster. And this is done in software engineering. The similar thing is generative design. You just learn by designing, by using it, and get back to the original design. Intelligent models, I think this is what we have seen, or we will see it in a minute also. We're talking about the automotive industry. Advanced robotics is clear. We can do much more today what we have done in the past. It could be even the smaller things could be done with robots. Machine learning, these machines could learn automatically. They could really learn, they can make some conclusions, they can even come up with some proposals. And additive manufacturing, as said, I will not go in depth in additive manufacturing because, to be honest, this could be a session on its own. You could easily speak about 4, 5, 6 hours in a row on additive manufacturing, all the different aspects. But it's important, it's really important. And if the kingdom would like to focus on something, because you start from scratch, really, why not to focus in the first wave on additive manufacturing? This could be interesting, because this is really how things could be changed. And lately also the ways product evolved, so we're talking about cloud. It makes life easier in maintaining software and providing solutions, centralized databases, big data analytics. We'll come back to this in hopefully some minutes then if we talk about MindSphere. And knowledge automation. This is a little bit, this goes along with intelligent models and also the generative design. These are really the points when we are talking about Industry 4.0. And if this now embraces the technologies the companies have to use, we are talking about the value chain, and this is ideation, realization, and utilization. This is again the whole value chain, just taking the 3 other words. Yeah. This is when we are talking about Industry 4.0. This is the scope. This is the scope Industry 4.0 is defining. And now if we look into these different phases, we have at least, we see 5 different phases. We have the product design here. We have the product planning. Design is just the designing of the product. Then we have the production engineering, which means that we have to make whatever was developed coming alive in the factory when it's manufactured. Then we have the production execution. We have to make it, manufacture it. And we have, at the end of the day, we have to provide services to maintain it, regular inspections, whatever, improvements, optimization. I think you know what we are talking about. Now in this, and these are well-known faces, no doubt on this. But now what's happening is that if we would like to optimize them, we have to have what's shown here. We have to have a certain backbone. So we have to really combine all these different faces, and we have to have a common database. We should avoid that we have any breaks from the IT backbone, that we have at least shared data, which is also known from the next application. And this is what we are going to do. And using this, which means then we can shorten the life, we can shorten the whole process. Right? Because we just need not the time where we have breaks in our background, breaks in the data flow, and this is where everything gets shortened. Right? And to some extent, it gets also a little bit easier. And now if we look, this is what we call then the MindSphere, or also the Industry 4.0. So we have different applications, and we will see what does it mean. But the more important thing is, and this is thinking from the back, so once we have the products out in the field being used, then we gain a lot of experience out of that. And this is also part, especially if we come with smart service built afterwards, where we gain all the experience, which is either used in the execution of production, where we get some improvements for the design, and even we can get some new ideas for new features of a product, which starts from beginning on and just improves the product. But even then, we would have much shorter times to make it happen, because we are going, everything is digital, we can use the digital twin, and we can save some time. If you look now for the whole production process, and this is what I said, we have the whole value chain what we address. If you look to the value chain again, and this is also an interesting aspect, we have two different views on the value chain, especially if we talk about manufacturing. The first one is, we have the company who's doing the product itself, the product manufacturer. Sometimes they are called OEM, original equipment manufacturer. He's developing, he's manufacturing products, he's selling products to the market. This is one perspective. The second perspective is the perspective of the machine builder, because within the workshop, they have different machineries there coming from different companies being used during the production process. And those have a perspective on the workshop. Because once it is established, then the machine builder has to look, what is the concept? So how is my machinery used? Yeah? The first thing, the OEM is looking if the product is okay, if the quality is okay, if it is like designed. But then also the manufacturer of the machinery being used could use remote controls to see if the machinery are working properly, if they could be improved, if this could be becoming faster, for instance, and if the machinery is getting faster, for instance, then this could be a competitive edge for the machine builder, but could also be a competitive edge for the user of this machinery, which is the OEM. These are the two perspectives out of this, and both are applicable to the kingdom, because either we could also think about building machineries, but actually we think more starting using these machines.
Quick question.
Yeah.
We can go kind of into the previous slide.
Okay.
Now, Saudi Arabia has a strategic part of the 2050 to increase the contribution of small and medium-sized enterprises to be 30%. So there is even during this conference, there is another conference, so this conference.
Was there yesterday?
Yes, there is a huge emphasis on small, medium. So if we look at this model, where do you think for example, if you look at this from Saudi Arabia, where SMEs could play a good contribution in this model?
I would like to answer your question in some minutes, because I have slides for this once we come to the KSA specific part. Okay, so now this was a little bit about the background and just a little bit about Industry 4.0 in general. Any questions to that? Because then I would like to have a short example. It will be a great example, but it will be short, with some animated slides on how it is used in the automotive industry. No question, because then we just go ahead. We have just this is a short movie without any audio, but it shows really how a modern automotive factory looks like and what could be done. And okay, this is just the warm up for that. So now we'll see a lot of animated slides. So this is first designing the product. Right? Well, everything, even today, starts with a clay model. Huh? So the designer has a model made out of clay and is showing this, and this is the new car, this is the new shape, they have a certain policy. But then, afterwards, everything is done digitally. There's no new car which doesn't use any new computer and new design software, 3D design software. And they could easily change it. They could easily change the shape. They could squeeze the roof. So it has to withstand the weight of the roof, just to save the driver and the people in the car. This is done here, automatically. You can just, you know what the car will weigh. Then you put some force on it, and then you see where the different stresses come from, if it's okay or not okay. And then you can minimize or maximize this. You can optimize it. So it's not just a matter that you make it strong, but you could have maybe, if you have sheet, you could make it a different shape or different folding, and then it's becoming stronger. This can be done in a very early stage. The other thing, this is an example coming from General Motors. It's about the simulation, not just about a single feature of the engine of the car, but of the whole engine. So we have seen the engine before, and now the engine, you see, it drives up, and the color changes as the engine is running harder. It's consuming more fuel. And you know the efficiency of a combustion engine in a car is very, very bad. It's less than 40%. So if you would run the turbines with 40%, you could let a lot of complaints from customers. But the engines we are using in our cars are really, really bad. So, but you have seen, it's climbing up the hill, then the engine, you can see what does it mean? Stresses for the material, stresses for the engine. And you have also seen that we can even simulate more. You have seen that it's like a wind tunnel, with the fluid and everything. This is also what could be done here. The next one is, it's not limited now any longer to the engine and to the mechanics. It's also now we are able to simulate the electronic systems in a car. Do you have an idea? It's always the question. If you take a standard BMW 5 Series or Librius Mercedes, what do you think? How many motors we have in such a car? I'm not talking about the engine. I'm talking about electrical motors. How many? Just to show it up, the average is about 65 to 70 motors. It looks amazing, but if you look, just the mirrors. Yeah? Each mirror has two. It's flipping here, it's flipping there, and if you can flip it in general, there's another motor there. The seats are going up and down, they're going back and forwards. The backrest is adjustable. At least in the seats you have 3 to 4 motors. And think about the air conditioning. We have individual fans, we have individual fans in the back. Or about the wipers. So there are a lot of examples. And we count them up, you really come exactly to 60, 65, 70 motors. And this number will increase. The other point is we have an idea of the computational power of a Mercedes or BMW 5 Series. Compared to Apollo 11, the moon, the first capsule landing on the moon, what is the average? But actually, the power of a car is sometimes be 30 to 40 times stronger in a car of today than the computational power was used in Apollo 11 to get down to the moon.
Car is more power.
Yeah, 40 times, not 40%, 40 times. So. Yes, this is really, and this is how we can also simulate, because we just acquired Mentor Graphics, is one of the big companies doing designing and simulation of electronics, and now we incorporate this also in our suite. And then autonomous driving, the next thing, this is a test bed, we have also acquired a company now. Now we can also simulate what does it mean autonomous driving for the car. Even before we have the first test drive, we can simulate this, and you know exactly what the reaction will be, what are the bottlenecks in computing, whatever is necessary. This can be done. And out of this, now we can create the digital twin for the product. This is clear. So we have done software simulation and design. We have done the electronic design and simulation. We could done the mechanical and the environmental design and simulation. And we could also do now the simulation of complex traffic scenarios for autonomous driving. This is what's called the digital twin.
So the complex traffic scenarios for the driver
No, it's not for the driver, but for autonomous driving.
Autonomous driving.
This is the AI driver. The AI driver. Okay. So now, if you look now for the next step, and then we're talking about production. So if we have everything in data, whatever we need in production, this is available. And once we have a design freeze, data could be passed over to the production planner. So he could start thinking how to make it. He could send out RFQs to third-party companies who deliver these things. So this could be much faster, much earlier, and much easier. So now, afterwards, somebody has to plan the workshop. Right? So this is also done today with a computer. So you just pick and place your different machinery there, the robots, and then you can also do the grand totals, how much energy they use, how much pressure air they use. So you can have also the design of the auxiliaries in principle. This is done in parallel, speeding up. Still, the design process might be in place, but as long as it has no impact on these workshops, this could be done already. Then, once we have done the design, we have the software today which can really simulate the production. So we know exactly, we can place the different machinery, we can think about if the robots hit each other, this could be done there. We could also simulate real time how long it takes to get something done in the factory, so we know exactly the capacity of the factory even before it starts working the first time. There's an example. There was a new factory built from Chrysler many years back, and they made a late change in the design in the factory because they found out that the people were changing from dark colors to bright colors at this time, and it's still true today. And but they had only they had three painting lines, but it takes a long time on the painting line to switch from dark to bright colors. So they found out if we just add for a little of money a fourth painting line and have this dedicated to bright colors, we increase the capabilities of the factory in output by 25%, because we save the time in changing from dark to bright colors. And this is easy finding, which can be done by computers up front if you plan the production process. And still, we have some people in the factory, but there is a question how they interfere with the machinery, or the machinery interfere with the humans. And what we could do, you see the blue bubble, it's the arm length of the operator, and it shows where he can touch, or what he can touch. And finally, this is becoming green. It's saying he's safe, he or she is safe, because she would not be hurt by any computer, by any robot, and she could not touch anything which is rotating, which could hurt her. And this is could also be simulated up front, so increasing the EHS. No? And finally, once we have then created the factory, it's a matter of how to make it happen. And therefore, what we could do, we could use the design from the factory itself to make it automatically the code for the automation equipment. This could be done, and this is where we see our advantage at Siemens, because we could do the other design, the other simulation. We know exactly what code we need to program our semantic stuff there. This could be done. And once we have programmed the semantic stuff, we have also a digital twin of our own equipment. So now let's talk the digital twin of our own equipment. And this is a little bit what Internet of Things is. There are smart devices which can talk to each other, can exchange data, and now the digital twin of our automation device are talking to the digital twin of the factory and can just check if everything is going okay, which will, at the end of the day, and this is then the final step, which will be a faster and efficient engineering, and of course a fast and efficient commissioning, because there will not be big surprises once we get it done in the workshop. We have installed all the robots, all the machinery, we installed all the automation, and we have the first start of the factory, and the power plant would be known as first fire, and then we will not get big surprises there. We might have some minor adjustments, but this is really where all the things are getting faster and much more reliable. And out of this, we have now thought about the digital twin of production. This is the other aspect of this. And here you see also in product execution, we have a lot of other software available, or you have to have a lot of software available. And the left side here shows how you schedule the work and how you use and utilize the machinery. And this would be important once we start talking about shared manufacturing. So if we would like to share manufacture, we have to know which party needs at which time which machinery, and this could be done to get more or less to 100% utilization rate. It's just a less changing time. We have also document management, because still paperwork is necessary. If you look to all the regulations we have to have, we can link them down to the different processes. We can show what is really the degree of fulfillment on this, and quality assurance can be planned and can be supported also by a lot of software there. So at the end of the day, we are talking about the full chain, and this is really, I think it's worth to mention, because still we have to make some business out of that. But we have some competitors in the area of PLM software, designing software. But Siemens is the one and only software company in the world which can provide the whole value chain. Because we are also the market leader in automation worldwide, so we can have this link. And we are also one of the 2 big companies doing this PLM software. So this is really unique. And well, the other thing is, as I said before, additive manufacturing with 3D printing could be a topic on its own, and this is also cybersecurity. Because we have seen a lot of networks, we have seen a lot of computers sitting in the factory. Also talking to the outside world, we are talking about third parties that are being involved in the production process. Which means that we have to have also a concept, and this is also what we are prepared for, but I would make it short just with one slide. We have also cybersecurity as a non-functional feature which is considered in designing the products. Not just get it thought about at the end of the day, but we did have it as one of the non-functional requirements. We have services, available consultancy services. We do something also for Aramco. I think we can mention this. The main point here is that we are talking about OT, because I don't know if you're aware of the IT is the normal office or the normal IT backbone what you have, and OT is operational technology. IT-OT, and this is the point. Because normally the workflow today is connected also to the enterprise resource planning system, which means there's a link in between. And as we have normally a pretty good cybersecurity planning for the IT part, OT part is new, or they have their own. And this is why we see really a lot of importance in having a proper design, IT and OT together. And this is really what's necessary. And there we can offer all the services and everything. We have a certain strategy which is called defense in depth. This is for the experts, but also cybersecurity, as I said, it's a topic of its own. This is the result.
I think first and foremost with the Ghibli we wanted to produce a new Maserati, meaning that the Ghibli adheres to the core brand values of Maserati, being Italian style, dynamic performance and refined luxury. The challenge obviously in terms of launching higher volume cars within a modern manufacturing facility, state-of-the-art manufacturing facility, is to retain that bespoke feeling within the cars, which is very much appreciated by our clients.
Being able to work in a digital twin is a significant evolution compared with the past. By using integrated software such as NX and Teamcenter, we can have an interface of all the teams developing the project on the same mathematical base. This allows us to reduce analysis times and to avoid possible errors caused by miscommunication between the different teams.
We can say that one of the strong points of Siemens is the fact that we offer a product portfolio which covers both the manufacturing and the engineering side. And what's more, these products are also tightly integrated.
l'impatto degli strumenti Technomatics.
The Technomatics tools are above all useful in the analysis of the product and in the simulation of the product line. Earlier planning and development know-how is thereby incorporated and implemented in the overall design.
Utilizzare l'esperienza del brand nel design della.
The aim was to produce 3 times as many cars than before, while maintaining the same level of quality, which is obviously higher simply because it is a Maserati.
Well, CAS is an integrated system used by the entire Fiat Chrysler Automobiles group and is also installed in the Maserati plant. It facilitates the management of the plant with Siemens PLC and HMI hardware with WinCC and Step 7, delivering all the diagnostics of everything that happens in the plant in real time. So Siemens technology helps us to be more efficient and have better quality management in the production plant.
The expertise is not only in the tool, so not only in the software, but above all about how to use the software within the setting of Maserati and FCA, because that is where we really make the difference.
Okay, so this was just proof that what is achievable. And Maserati, they really shortened the time dramatically, developed this new car, and make it available to the market. Okay, we still have the stamina to go to the next topic? Okay, because we have hands left.
I get a small sort of question.
Yeah, sure.
Do you think it's a bit risky when you apply this kind of revolution with the poor infrastructure, communication infrastructure?
Well, this is why I said we are going, or right now we are talking to authorities in the kingdom. And this is a fourfold discussion that we have. The first discussion is on people. And what we can do is we do. So we work with universities. We donated this kind of software which is used here to get really the right people educated and make them available in the kingdom. That's the first prerequisite, because this is what we have, always have to repeat this. Vision 2030. It's about people and it's for the people. Because at the end of the day, the result is to have a better life for all the people in the kingdom. And it's not just to do whatever. But it starts with the people. So they have to have the right people, and this is what the second one is the infrastructure. Sure. We have to have a proper infrastructure. We're not talking about just having another industrial city, but we have to have the right logistics there. We have to have also the administrative environment. I don't know if you are aware what it takes to get something inside the kingdom, if it's coming from abroad. Customs clearing is not that easy. There's a lot of things, but even getting things out which are not normal. So we're just doing something with Aramco, and we had to ship some barrels of crude oil out of the kingdom. This was a nightmare. It took us, I don't know, 3-4 months to get it done. And once it arrived in Germany, we found out that even Germany is not better. Because it arrived in the northern part of Germany, we had to ship it down to Frankfurt, and we got it on the truck with the wrong license, so it was not able to move it out. So it took another month to get it really very close. But not environmental, all the administrative stuff is necessary there. So infrastructure is there, but also technologies have to be there. And then we have to look for the applications. And applications mean that we have to look which kind of industries we would like to focus on in the beginning. Of course, this is really what all of you have to be aware of. We are competing in the kingdom, not mostly to companies in North America or in Europe. The competitors for the kingdom are sitting in Asia. They are sitting in Philippines. They are sitting in Malaysia. They are sitting in Vietnam, in Myanmar. This is really, and
the size of the market in Saudi Arabia, even of the Arabian Peninsula, is not that big that it would be able to do these high investments. So it means whatever is done here, we have to have the perspective on the world market. But going out to the world market means we have to be competitive to the world market. And this is why we have to have in mind, whatever we do, we have to think globally.
Yeah, and this will lead for another question.
Yeah.
How much it would cost to apply this kind of revolution when adopting the planet? As a percentage,
I have no idea because it depends. It depends really which kind of industry we are talking about. If there is something already here, and the more interesting question would be now how much money it would be, because I think money to some extent is not the problem. But how long would it take to get it done?
No, but we're talking about seniors. Most of them individuals, so they take care about money more than governments.
Yeah, but the other side, well, but you see, as I said, we are talking to ministries. Of course, we are doing this because we are not a solution army, for sure. No? For sure. So we have to earn money because this is also the expectation of our shareholders. But on the other side, we see also, and a lot of my activities, if we are talking about industry, university relationship, this is part of CSR, corporate social responsibility. This is really what we think. And this is where we offering also our consultancy services to the kingdom to make it happen.
See, Dr. Back to my good comment. See, now infrastructure is not only the infrastructure.
No.
For example, R&D. We talk about knowledge-based economy. You have to have a foundation of an R&D that takes the entire R&D innovation from the idea to the market.
Right.
And this is a challenge for us.
Yeah.
Because universities are focusing their effort on basic, fundamental research, blue sky type of curiosity-driven research. While we are an industry, we are looking for technologies based on applied research that address challenges. Now, without having that link with R&D here, even on the left side, says SME initiative, knowledge-based economy, without having a box that says impactful R research and development, we will not be able to address the four industry revolution challenges.
Yeah.
We will. This is a big challenge.
I think this is a very most important point forward.
Yeah, sure. This is what I said. Well, we are working on this together, and hopefully we will be successful. We are prepared really to support whatever we can do. And you will see this now on the slides, what we think, what could be.
Because I tell you, Professor Spear, you represent a multinational corporations. I was in Turkey attending a conference a couple of weeks ago in Istanbul. And many multinational corporations, they have a very strong and tangible presence in technology development. And we asked them, why Istanbul, for example? Because they said we are working closely with universities. We can tap into the talent of the graduates of the country. Why not Saudi Arabia? And I asked that question as well. Okay, well, yes, this is good. We know, for example, KPM, we know KAUST, maybe some know about King Saud. But again, they don't really look for us as a strong hub for doing research and development. And that scares multinationals. They go to places like India. While we are here in the United Kingdom has a great potential. We are not far away from Europe, we are not far away from the sub-Indian continent and in China. But again, research and technology and multinationals should help us. Multinational corporations who are working with us in this country, they need to help us working with the academia to understand how critical to have research and development done.
Well, I totally agree, but it's really a multifold problem which we have to solve together. And I think that all the latest news, what we got from 2 weeks back, 3 weeks back, with the announcement of NEOM, the new city and the new environment, I think this is going exactly in the right direction. Because it addresses R&D, it addresses new industries, it addresses a different way of living, and even to have a little bit of a different landscape for people living and going there. And this is necessary. I know exactly, as I said in the beginning, I'm the Siemens rep at KAUST, and from the environment, but we haven't done really a serious project with cars. We are just paying every year our fee, but the point is that it's not really related to our business. Or to some extent, many of the universities ended with ST. So we have science and technology, but sometimes it's more science than it is technology. Yeah? And we have to really focus also on technology.
Is right?
Yeah? This is, and well, there are a lot of problems, but I think the latest development, especially let's say during the last 1.5 years, it's moving. It's moving also fast. It's taking up a little bit speed. I'm quite confident that at the end of the day it will be successful. But there are also some other comments what you can hear is to be really straight and honest. If you look to the history of people living in the Arabian Peninsula, there is not really a long history in manufacturing. Arabia lived pretty good, very long time in the magic triangle between Europe, Africa, and Asia. On trading, because you were perfect. On trading, but not on manufacturing. Even your carpets you got from abroad at this time. And this is really also another aspect. And we should not go in depth in this, but this is also an aspect. What some people have to think about if they would like to establish now, because this is also not in your genes, not from day one on, and it would take another one or two generations to get it really up and running. And this is also another aspect. So it's really a problem. It's really a manifold problem. And well, I'm deeply involved in the company, and it's the first time really that we are thinking also from the perspective of a country. Normally we are thinking as a company, we have to improve ourselves and blah, blah, but now thinking out of the perspective of a country is different. And I think nobody, and we haven't found, if you're talking about India, there are totally different aspects. And I know when I have about 2,000 people sitting in India writing software, I know what I'm talking about. And also having 500 people sitting in China doing hardware. Yeah? But this is really different. Now we are developing a whole country. We are shifting a whole country. We're not talking about a dedicated industry. India, call centers, software development, and movies. They are bigger in movie industries than Hollywood is, twice the size in India. But this is really difficult, and this is what we have to do.
You're the professor when I visited Munich, and we visited Siemens, and we visited a university next door, which is technical university. And this is the model that we'd like to see.
Yeah.
They have almost a twin relationship.
Yeah.
You have the faculty and professors and researchers and working closely with their counterpart, Siemens hired talent, and they are just 15 minutes from each other.
We have also the common practice in Germany that there is a group of people who is reviewing the curricula on the yearly basis. Not on each and every university, but actually each and every university is reviewed on a 5 years period. And the academia is talking back to the industry if the curricula are really top notch, if they are really supportive or not, or what really to add or what to change, or what to take off the curricula which is no longer necessary. And also this dialogue has also to be established.
And also I think it may take time. I think 2030 is not enough or sufficient time to move to industrial city. Doctor said, I've seen some article that said that the learning curve for some European countries like Germany take around 200 years. Mm-hmm. For China, since we have some technologies last year, it take around 70 years. So I don't think it's an easy to talk about industrial, with the 2050. Even the vision, they just, focused on the cities only. The government, they don't care about this. They have many things to focus other than the industries.
And it's also, we have to be aware of that it's not a one-time activity. It will not end in 2030. Independent of what we achieved in 2030, this is an ongoing, as you said, Germany and Europe, we have a 200 years history of this. And this is an ongoing process, and we learned a lot. We learned also a lot how to keep this process running and to really be always top-notch. And this is also what has to be established. 2030 is just an intermediate step what we have to achieve, and it's a nice number and it's a nice vision, but then it will have also 2040, 2050, 2060, it will be an ongoing process.
But Doctor, a country that you're familiar with, like Switzerland, is a small, tiny country. I think around 8 million people.
Yeah.
It's around 7 million, 8 million. and find Switzerland on the top 5 countries in the world when it comes to, like the Global Innovation Index, number 2. Competitiveness Index, global, number 4. The not the manufacturing, the entrepreneurship, talking about SMEs, they are among the top 5. Small countries,
Yeah, but it's
no
a
resource
from Europe. It's still a part from Europe.
Yeah.
We're talking about, it's not about the size. We're talking about Singapore. They just focus on the logistic. And
Yeah,
they
but also
don't-
on other things.
They don't think about industry or these things.
Yeah, but Singapore, for instance, they have a lot of research. I know ETH Zurich, this is one of the technical universities, the famous technical university of Switzerland.
Yes.
They have an own lab in Singapore. They go to future
Well,
Singapore, and they are doing a lot there. And Singapore is far ahead of all other countries in the world in doing smart city development. They have a lot of, but it's easy also. It's small. Singapore itself is small. And the political structure is easy. If somebody's saying we do that, they do that. They have also the money to do it. Okay, otherwise we run. If you have a little bit more time, then it's okay. Otherwise we have to be finished in 10 minutes. And this would give me a little bit of problem. Okay. Well, this is now how I think we could map it. And you have seen this now for a while already. We're talking about this just as an objective about an industrial city. And we have a lot of different aspects what we could get out of the Vision 2030. We would like to localize, we would to create jobs for Saudis, we have to have a diversified industries going beyond oil and gas. We would like to build a knowledge-based society, and we have also not new, but for the time being, the SME initiative. On the other side, we learned a little bit about Industry 4.0, about smart services. We'll learn a little bit later. And we have seen whatever comes from Siemens as well. And now, if we take this into the industrial city, this is how, in principle, an industrial city could look like. And so it's a smart city, but smart city in a different sense. So we could have a factory here. But if you look to automotive industry, to take this example again, we have a lot of manufacturing SMEs sitting around the factory. Because the factory, a car factory today, is nothing more than more or less the final assembly. The engines normally are done by the car manufacturers or by the car company, but all the others, like air conditioning, heating systems, exhaust, they're coming from other companies sitting around the factories. So we could have a lot of manufacturing SMEs sitting around there. We could have also engineering SMEs sitting around the factory. They could provide several services there. We could have serving SMEs around this. And nevertheless, we have to have a kind of a data center there, because everything is IT-based. And they have to share, if they would like to seamlessly work together, they have to have an IT backbone, which is called here the IT infrastructure. Then, as Walid said, right, we have to have also the development center here, because it's not just a matter to put the things here together, but we have also to improve them, to develop them, what is necessary. But also, again, about people, we have to train them. The training center is also obviously. And then we have also a lot of other supporting SMEs, which could be around logistics, which could be around catering, you name it. And now if we look, what does it really mean? And then we come to localization. If we apply the Industry 4.0 concept, then we learned together this morning that we have the full product lifecycle. I think this became clear during the presentation, from design, development, manufacturing, as well as after-sales services. But also, it ensures the highest quality, small production volumes. This is batch size of 1. But also, if we have this one, and if we would like to have global companies here in the kingdom, this enables also a close link to overseas headquarters. So we can easily exchange something. It's not a given that everything has to be done here, nor it's a given that everything has to be done in the headquarters and the final product is shipped. So this could be a different kind of division of work. Yeah? And we could also have, and this is one of this, I think this next slide then, we could talk about the seamless integration, the seamless link. We could talk about the seamless integration of SMEs sitting around the factory and how they contribute to it. To give you an example, if something is done, let's say the air conditioning system of a car is done in SME and it's shipped, it's just moved into the factory. and they have a quality assurance test at the end, that they tested that it's working. Is it necessary if they share the data, how it was tested and what was the result, that the factory side, the test is done again? No, they can share the data, and it could be faster, and it could be more efficient and time saving, and also on lower money. Now, if it comes to SMEs, this is also interesting. We could think about new cooperation models between the SMEs. So even if everybody goes on Industry 4.0, there could be a lot of closer cooperation. There could be a lot of faster cooperation, which is really to squeeze the whole PLM cycle until we get something started in the factory.
What is OEM stand for?
It is original and equipment manufacturer. These are the companies who, this is like Mercedes is an OEM, and Bayer, for instance, is a company who is doing, it's not an SME, but they are providing the sunroofs, and they are providing also the air conditioning systems to cars. But OEM is normally original equipment manufacturer. Whatever the brand is on the final product, this is called an OEM. So then sharing a common database could be local SMEs. It's also SMEs are also global to some extent, but they could also share the data with their local headquarters, with their global headquarters, anywhere else. And this is also one thing where I see that we have to lower the hurdles to get them into the country, because many of them, they do not have the same overhead like we have, all the different departments taking care of a global business. SME is sometimes is privately owned. There's a family owning this for many, many years, but they do not have a big administration thinking about how to get to Saudi Arabia, also to file all the necessary documents. This is also something what we have to change here if we're talking about implementation. This is another thing. And then we could also have new service models according to this smart service web, what I will present in a minute. And the other thing where I do not have a slide of is now shared manufacturing. And this is also part that I think could be really a key component for SMEs coming to the country. Because guess what SMEs, especially the SMEs, the small ones, as well as startups, all have in common they are shorting cash. Sure. So they normally can't afford, especially if you have a startup, they can't afford to invest heavily in some workflow or something. Yeah? So the question is now, if you consider modern, they have a new city, and they would ask several SMEs coming to this city, having their offices there, but all these SMEs should have a similar setup concerning what they need in the workshop afterwards. So then they could establish the IT backbone, what they have actually. Maybe it's necessary to have a little bit stronger. They could rent to the SMEs software or a software suite which is able to address the whole link there. And out of this software backbone could be connected to the workshop. And then if they have the proper software in doing the schedules, they can utilize the software in a shared manner. So still the new methodology, shared is the new owning. So they have not to own it, because they can share it. And then it's up to whoever runs this, example would be Moda, that they have the proper schedule, that they guarantee the highest utilization of whatever is there. And the business model behind this could be that they could have a pay-per-use, pay-per-time, or whatever. Or they can even own it and can just offer the space. So there are different business models. But this is an idea how to make SMEs much faster and much more competitive from day one on. And if the government decides, okay, we can subsidize the same that we own, or we subsidize the workshop, whatever is installed there. This is another way to make it cheaper for SMEs for a certain period of time, to give them a little bit of financial support in the starting phase. This is really what could be about SMEs and shared manufacturing.
Where we can find this concept, this is shared manufacturing? We go.
I've written a white paper. And who's interested, just send me an email. I should provide the white paper.
In shared manufacturing.
Not shared manufacturing. So then, if it comes to SMEs, then we can also have SMEs who could provide web-based training and more. So if we have to have seen this, whatever we can whatever we could simulate in the computer. We could have web-based training on this. We could train people, train how something looks like. And this could be done by an SME or could be done by the OEM company. So this could be a shared database on all the stuff they have in the manufacturing or in the factories. And they could also get automatically feedback. So this is one thing which is also a new possibility, which is caused by industry.
What's the percentage contribution in Siemens, either Germany or globally, SMEs in your business?
Well, I'm not aware of this, but I think it's if you look to automation, I think it's at least it's equally. I would guess even that SMEs would be bigger. Because in Germany, well, the German economy is known for the big giants like Siemens, like Daimler, like Volkswagen and so. But if you look to the southern part of Germany, there are much more SMEs that nobody's really aware of. And this is a big market. We have a lot of companies doing either supporting the automotive industry or having their own products. For instance, we have Seal, we have Pabst, they're doing fans.
The size is big, right?
But they are small. These are companies which are not known really, but which have revenues about €1 billion. This is really the interesting part is, and this is a figure normally people are really astonished about, that around 80% of R&D is spent by SMEs in Germany, not by the giants. 80%. And this is really where if we
why they're getting the funding? There is a venture capital or?
Well, venture capital is not that strong in Germany. This is they're not that strong. No, they have to. No, this is family-owned business. So whatever they spend, they have to earn it before. They pay out of their own pocket. So sometimes they get subsidized. They have a program coming from the EU or coming from the government. But normally, this is really the financial strength. This is the strength of German industry.
There is an online website for in America. If you want to invest in startup, you see the startup company list.
In Germany?
No,
anywhere?
It isn't that in a lot of websites.
Just
click, read the company profile, you can talk to the people.
But as I said, startups now, Berlin has changed a little bit. The most interesting city for startups might be Berlin now. Berlin. This is to some extent, nobody, I don't know why. I would assume it would be more Munich, because this was really the focus city in the last 2 or 3 decades in Germany. But now it's becoming Berlin. I don't know why. But as I said, venture capital is not that strong in Germany. We do not have really the history like the US has in venture capital. But it's much stronger. And also, the treatment of people who failed in starting a company is totally different in Germany.
How?
Because in Germany you get blamed once you have failed with your first startup. Yeah? In the US they say, well, he learned how to do it, not how to do it, give him a second chance. And even he could get easily a third or fourth chance. Getting a second chance in Germany is quite difficult, to be honest. But this is now we shouldn't get philosophical. So now the next one is, and this is, I think we discussed this already in the morning, is this is also a little about the strengths and what we are also going with NPA, for instance. I was writing curricula, these proposals for curricula when we are going in NPA, and I took this out of from the German government. There's all the curricula from the different grades what we have in Germany are available. Unfortunately, they are all available in German, so I had to translate them. But I brought them here, and we are talking to the Ministry of Education, we are talking to the Ministry of Energy, Industry, and Mineral Resources, how we make this happen. And this is also one of the engagements. And this is also necessary, as I said, people. It's the first prerequisite that we have to solve to get Industry 4.0 happening. And then, just to make a long story short, there is this industrial city based on Industry 4.0 is also a smart city, and there is a lot of more what a smart city makes. It's the road and rail, the infrastructure, transportation. Then we have power and renewable and smart grids, and finally also the smart buildings. But I can't go through because otherwise we run really over. So just a few words on MindSphere, on the IoT platform. This is the last part now of the digital twin or the whole coverage. And again, There is a paper, and people who are interested, I have 2 paper copies with me here, and it's about the Smart City Belt is about use cases given here. It shows what platforms are needed. They have to be open, they have to be connected, they have to be secure and safe, and also the cultural change in business and what to do there, and also an innovation-oriented framework creating a different environment for Germany and also for Europe. And also a short movie on this digitalization.
Our world is becoming ever more connected. Billions of intelligent devices and machines generate massive data, bridging real and virtual worlds. Complex data now play a crucial role in the way we move, live, and work, the way we plan, and create products and services. Turning the vast amounts of data collected every day into value is a key success factor for companies, economies, and entire societies. We have the domain know-how to transform the big data generated by our systems and products into rich information that enables smart choices. Our data-driven services monitor power plants to guarantee reliable energy supply. Our software and IT solutions teach wind powers how to produce more, and our building management systems teach buildings how to consume less energy. We enable our customers to intelligently automate processes across the entire life cycle of their products. And by simulating real-world objects by means of digital twins, we help them optimize their manufacturing processes. Our intelligent traffic management systems help moving people and goods faster, safer, and with less CO2 emissions. And we develop sophisticated medical imaging systems that help doctors make better decisions faster. We seize the data opportunity to create real value.
Okay, this was just a short movie on digitalization. And again, we have to finish the whole chain of the product lifecycle management now with the last phase of monitoring, and this is what we are doing, what we call MindSphere. It's a cloud-based IoT system which is, has a levelized approach. You will see this. We have a lot of partners there, so we're not doing everything by our own. The web services that we use for the cloud are not fixed. We could use SAP HANA, we could use Microsoft Azure, we could use Amazon Web Services, so in this respect we are flexible. And the platform itself, it's open for third-party companies. It's an open architecture, it's also an open software approach. And this is then also the digital twin of the performance and whatever the products are being used. We can monitor it, and what we have seen before, that we create a feedback loop into the manufacturing, into the development, and also the design process. This is really the prerequisite to do this. And you can see this here again, go to the product and go to the production. So MindSphere, just very briefly, it's interesting that 50% of data is created in the last year. It's unbelievable, whatever we have here. But only 0.5% is being used, or being analyzed. It's also interesting. Another point is if we are talking IoT, whatever this thing is, but if we count it properly, 5.5 million being connected each and every day. Every day. This is unbelievable what's happening, and we expect to get to about 50 million by the year 2020. So it's really, the world is becoming more and more complex. This is now what MindSphere is about. In the middle, we do have a cloud-based database. We have a lot of equipment on the lower level, and the lowest layer here we call it Mind Connect. It's the Mind connectivity. We are based on the OPC UA, And so we have the protocol, we have also a software stack now available. We are not fixed to Siemens equipment, we can also incorporate each and every third-party equipment if it's using Windows, if it's using Android. We have a software stack available supporting this. Data is going into the database, and on top of this we'll have our own web store. It will be not the App Store from Apple, it will not be the Play Store from Google, we'll have our own, which is dedicated to industries. But there are several other things, but the web store also is open for third parties. So you could develop as a single entrepreneur or as an SME in development, can test it, can upload it, and can market it worldwide through the web store. This is quite simple, and we are going to launch this very soon here also in the kingdom. This is the open platform, as I said, and we provide this platform as a service. This is again saying what I explained before. We have different partners out of the IT industry for the middle layer. We have an open architecture concerning connectivity, and it's an open partner ecosystems concerning whatever is available on top. We have some Siemens applications which are really top-notch. Data analytics, we have a tool which is used now for more than 15 years also internally in the company, and we made this available now also for the industrial public being used there. This is again just whatever can be done by third parties. They can do consultancy services, they could run applications, provide certain technologies, run as a system integrator, also as a solution provider in general. So this is just advertising, just some examples of what could be done and what is be done now. We can do fleet management, this is shown for wind turbines, but we can also do fleet management for combustion turbines, power stations, you name it. We have also predictive maintenance. This is coming out of our strong analysis. The next one is also not, it's predictive and prescribing maintenance. Prescribing means also that we learn a lot and also set up and give something back to the process. And so we have active security. I think this is a prerequisite if we start talking about cyber physical systems and IoT. We discussed this before. We have product intelligence, a lot of cyber physical system embedded controls is going into. We have a lot of examples out of that. And we have some showcases on religion is one of the solutions we have for the rail industry. We have a contract in Spain on the Spanish rail, and we came down to functionality for the high-speed train between Madrid and Barcelona of 99.9%. So this is really perfect, and we got really a big utilization rate, because they learn during the ride from Madrid to Barcelona or vice versa what is wrong in the train. And once they arrive at the station, spare parts are there. It's like a Formula One pit stop. So once the train comes in, and it could be fixed on the fly, it would be fixed in a very short notice and in a very short time. Navigator, we are using this for buildings. That's also available and part of the MindSphere. You have seen the 101 tower in Thailand. This is one of our biggest showcases here. It's one of the tallest buildings in the world. It's the first time that the safety and the security system and the building management system was combined in one. And this is now remotely controlled and remotely monitored. Everything is about MindSphere, and we call it the industrial IoT platform. Then briefly the summary, because otherwise you get hungry. So what you should take with you is we have talked about the production and the product design. We talked about the cyber physical system, and we talked about the production network. These are all the cornerstones of an industry 4.0 approach, but there are much more. We talked about people, we talked about other things. We have not talked about industrials of 3D printing. This is something which would be a topic on its own, but we are very active. We are doing spares already. We are printing today plates and mains of turbines, which is really heavy stuff there. So we are not related to polymers. We are doing also metal, whatever, with laser printing there. We are also using decentralized energy supply. This is another area, but also industry 4.0, where at least the digital twin concept could play a certain role. If you're interested, we could have a chat afterwards. We have intelligent infrastructure, so whatever we are doing, we can also simulate smart cities. This is also important. You might have seen before in the movie these traffic solutions, what we have, and also e-ticketing and multimodal ticketing is something that could be done here as well. Artificial intelligence, we are doing a lot. We have a full group sitting on different locations in the world working on this, and this is going step by step into our products as well. And we're also talking about mobility of the future. We are not delivering electrical cars, but we are considering to build the infrastructure around this, what's needed by sensors and feedbacks and communication, Car2X, whatever is necessary to navigation system, to certain infrastructure. We are developing parking solutions, which is driven out of the light poles in the city. We have pilot projects in Dubai on the main road where we have the light poles radars installed, which are monitoring free spots, and you get guided automatically. So this is the final slide, fourth industrial revolution. I think I explained it. It covers the whole value chain. Costs are minimized, time is shortened. A smart service world could be the logical extension of this. MindSphere is the platform, and building new industrial cities based on Industry 4.0 or building actually new industries is really a big opportunity and possibility to really get the kingdom to step further. And by this, well, we are almost done, except you would have some questions.
A quick question.
Yeah.
Thanks for the presentation. Definitely the Industry 4 will change the global supply chain.
Yeah.
You did not mention for your presentation, but the question is, one of the objectives of Vision 2030 is to increase the local content. And the challenge now of the global supply chain will change, and I think the competition will increase between the vendors. How can our local manufacturers can compete with the other outside of, in terms of the vendors and etc. to increase the local content?
Well, the point is, I think we discussed this a little bit before. Industry 4.0, it's a matter of how to introduce it, but also how to maintain it over the time. Because after 4.0, there will be a 5.0. You have to establish also a certain R&D. And if you talk about a global environment, this is a given. You can't discuss it away. And if you would like to be successful, you have to address the entire chain, whatever is necessary to build it up, to maintain it, to use it. And if the kingdom would like to become competitive, they are facing the worldwide competition. And thus it would be also a strategic decision which industry you pick, which industry you think you can do best. And from an obvious point of view, it could be energy-intensive industries. Because energy is still cheap, you have enough here. And this might be a chance. But on the other side, there are also bright minds in the kingdom, and if they are allowed to think out of the box, and if there is money, there is venture capital there is money here. Look what Leo will be, so Leo will be one of the shortlists, but there might be a lot of other opportunities. And then you have to start with and take it more as a challenge and not to see all the obstacles.
But let me just try to answer the So we have a local content for us, Saudi Aramco, as a strategic group. So we have by the year 2020, 70% of organizations that want to do business with us, it should be localized in terms of procurement, in terms of spending on training and development, spending on research and development, and supporting the technology. 70%. They don't meet the target by 2021, we will not do business. So this is something we're forcing.
Okay, what about the competition with the others, like pricing, etc.? Is there any margin? Definitely, we're looking for profit. So
what in our situation, still the criteria for procurement, contracting, still the same. But 70% by 2021, if a company X that's doing business with us, they don't have 70% of their local content. This is the target. They are working now left and right. 2021 is just around the corner, and the same as we are one of our partners. So 70%, this is the target that we set. So this type of thinking goes with other companies in the kingdom. You will find that it's a game changer. Okay?
What's the challenge?
It's a challenge, 70%.
What is the role of Siemens in medical device industry? Medical device industry. I know Siemens, they are pioneer, they trusted imaging. Globally, what's your major share? Just Europe or US?
On medical devices?
Yeah, medical device.
On the kingdom, it's quite easy. It's almost 3 digits. If you talk about scanners, and there are not that many companies left. We have our major competitors like GE, Siemens to some extent, HP. So I think it depends a little bit if we're talking about diagnostics, if we're talking about scanning. Scanning, I think we are the market leader worldwide.
Do you think this type of recruitment can be utilized?
Well, we are doing, we are not, well, manufacturing facilities are existing, and still in the market is a kind of overcapacity. So there's no chance to have something here, but we are doing in the kingdom concerning healthcare, concerning scanners, is we are doing engineering here, and we are doing R&D to some extent here, because for the doses. So we have a lot of cooperation with hospitals, where we really try to get best images with lower doses. This is what's happening.
So GE was about to start, but it's so medical device, there's no clear picture. The opportunity is very high.
Actually, we have a big market share here. So we have factories in China, and the question is, at the end of the day, and this is still what's going in line with before, is it really competitive if we open up another factory here? Because we do, to be honest, first question is workforce available, skilled workforce available. If we have the workforce being focusing on being built with residents, it's ridiculous. So we will not get really competitive to this if we compare it to China.
No, the demand for healthcare is already very high.
We know, but we are serving this business. We are serving this business competitively.
The total number of surgeries in Europe is 53 million. In Saudi, we have one. Just you see, Dubai, what's 90% of medical devices are here in the airport.
Yeah, sure.
And because of we have the plastic, especially the polysulfate, which is this sector can be utilized.
We are
especially in critical care, not diagnostic, production is very common.
Well, we are reviewing this.
I'm really interested in that one. I'm thinking in this direction. Since some time, we're studying the polymer. I think can add a value to this industry.
Well, I'm full supporters to get everything what's possible established in the kingdom. But think about, we have 30 million people living in the kingdom. Siemens has right now, if it comes to CT or MRs, 2 or 3 locations for manufacturing for the worldwide market. No, for the worldwide market. The worldwide market, we are talking about 7 to 8 billion people. Serving other 3 factories. The question is, why to open up a 4th one for just 30 billion? To be honest, this will be lost money. Because it will not be competitive. Because we will not be able to load this factory.
I'm not speaking about MRI, I'm speaking about vital sound, monitoring.
What we can do, but we are doing that. We are doing this. We are providing remote services. We have experts sitting here and doing remote services.
Yeah, I know the computers doing fine, but for some accessories, like the plastic-based device,
if you could show me the business case, sure, we can discuss. Okay. Any else? Any other questions?
I just wanted to say that the problem of all our countries, especially for industry, it's not start from product design. We are more direct to take technology from outside. That's why until now we are not we didn't have a search center, any factories, or even industrial center. We don't have search center.
We are looking to establish a sustainable industry. And if we would like to have a sustainable industry, we have to have.
We must be here.
Otherwise, we won't be. Sure. I'm not saying that it's easy. It would be that easy.
It's not easy. No, it's not easy.
Well, the whole vision, to be honest, the whole vision 2030 is great, but it's not easy going. This is a hell of work. It's a hell of work. It's a hell of coordination necessary. It's a lot of thinking out of the box. You have to stimulate people thinking out of the box. You have to give them the freedom to think out of the box. So it's really
Yes, that's the point.
Well, I think if we're done, I have just one question. Was the format for you okay? Was the discussion okay? What could be done better if we have the chance to have another workshop? And then that's
I don't know about but they are not.
Yeah.
If I just ask for a suggestion, I think this is an excellent workshop, definitely. The feedback and the discussion. Perhaps maybe there is you are planning to have another version of this discussion. It might be worthwhile focusing, number one, showing the high-level objectives of 2030.
Okay.
Looking into the fourth industry 4.0, mapping those, and what is the gap between the industry 4.0 various components and currently ours. And then suggest some recommendations from a global company like Siemens. What's the best way for us as a team to bridge this gap?
If you give me another 6 months, we'll be through the discussion with the ministry, and we are able and allowed to discover many of these things. Because right now, it's to some extent it's controversial. Okay.
All right.
Thank you for coming.